Hey guys, my name is Tariq and welcome to another episode of Coffee Break Hacks, where in the time that it takes you to have a coffee break, you'll be learning a new hacking tip or trick or technique. In this video, we're going to be learning about the fundamentals of containers and Dockers and how you can create your own mini pen testing lab by installing Kali and Metasploitable on Docker. We're going to be starting off by explaining very briefly what containers or Dockers are, and then we're going to set up Docker on your machine, and then from there on, we're going to be installing two containers. One is Kali Linux, and the second one is the Metasploitable2 machine, which is an intentionally vulnerable machine that you can practice your hacking skills on. So let's start with a quick overview of what containers are. Now, there's a ton of tutorials out there that explain this in a lot of detail, so I really don't want to rehash everything that's been done. I'm just going to go through a very quick, high-level overview of what containers and Dockers are, and then we're going to jump into the more interesting stuff on how we're going to set up Kali and Metasploitable on Docker. So if you've never come across containers or you don't know what the concept is, let me start you off with how the concept came up to be. Imagine you're a developer and you're creating a web app. Of course, you'll be using your development environment for this. It would be a server that you most likely have full access to, that you can install dependencies on, you can install software on, you can develop your code on, and so on and so forth. At the same time, that server could also be accessible by other developers that are doing their own work, installing, uninstalling applications and whatnot. By the end of your development cycle, your application is working absolutely fine, 100% zero glitches. You move it to production, and then all of a sudden, it breaks. Things are not working as expected, there's some issues with the application, it's not even running properly. So what happened? What happened is that on your own dev environment, you had full control, you've installed the dependencies, things changed, versions changed, the operating system probably was slightly different, and then when you moved it to production, the environment has also changed. It's not the same dependencies, probably different versions from the ones that you have on your development environment. So that broke the application, and going back to try and troubleshoot exactly where the problem is going to take a lot of time and effort. Now imagine this. Imagine if you have your own dev environment where the application works absolutely fine. You take that dev environment and then you package it in one executable without the application. So keeping the application aside. Only your dev environment with all the dependencies, all the files that you need, the exact versions, the exact operating system and whatnot. And then you package it all in one executable. And then wherever you want to run the application, you can ship that application off to that place with that executable that contains all the necessary information and DLLs and files and dependencies that the application needs. And then you run the application with that executable and everything will run absolutely perfectly fine. This is the concept of containers. Think of it as a mobile app. So if you're installing, for example, Telegram app on any Android phone, no matter who the manufacturer is, no matter what version it is, considering that it's going to be a relatively newer version of Android, of course, it is going to work, no matter on what type of phone. The same goes for iOS. If I'm installing Telegram app on iOS version 8 or 9 or 11 or 12, it is still going to work. Unfortunately, it's not the same for web apps. So containers are a similar concept. You package everything that you need in one file, and then wherever you ship that file to, it is going to run exactly the same. And if you put an app on top of that, the app will run absolutely fine. Another way you can look at containers is that you can think of them as lightweight virtual machines. Now, it's not an exactly fair comparison with virtual machines. We're going to be seeing why in a moment. But if you don't have a concept of what a container is, for now you can think of it as a very lightweight virtual machine. And here's the difference between what a container and a virtual machine is. If you're familiar with virtual machines, you know that when you create one, you need to virtualize an entire operating system. So if I'm creating a virtual machine of Linux, for example, Ubuntu, I need to install the entire operating system of Ubuntu with everything that comes in with it, regardless of whether I need that or not. And then if I want to reduce the footprint of that operating system, minimize its size and so on, I need to start uninstalling and unplugging packages. With containers, the case is quite different. If you look at the diagram on the left-hand side, this is a diagram of containerized applications. So the way you can look at it is starting from the bottom up. Start with the infrastructure. This is where we have our infrastructure, the hardware, the servers, and so on. On that, you have the host operating system. Let's say, for example, that host operating system is Ubuntu. On that Ubuntu system, you're going to install the Docker application. And I'm going to explain what Docker is in a second. For now, think of it as the software that allows us to manage containers. And then from there on, you can start adding and running and removing containers. So for example, app A could be your Kali container. App B could be your Metasploitable container. And you'll notice that all of these containers will use the same host operating system. In essence, they're using the same Linux kernel of my Ubuntu, the Ubuntu host. Compare that to virtualized machines, for example. If you look at the right-hand side, you'll see that starting from the bottom, there's the infrastructure. On top of that, there's the hypervisor, which is going to be used to manage your virtual machines. And then for each virtual machine, you need to install an entire guest operating system. So if I need to install a Windows VM, for example, I need to install it with all its bells and whistles, with everything that it comes with the browsers and the drivers and everything that I need and that I do not need. And then on top of that comes the application. So you can see that very quickly, the size will mount up for each guest operating system that you install. And this is the main difference between the containers and the virtual machines. Now, I mentioned Docker briefly. So what is Docker? Docker is basically a container software project. It allows us to manage and handle containers. So we can create containers, run containers, add them, delete them, stop them, and so on. There are other container software projects other than Docker, like Kubernetes, for example. But the reason that I chose Docker is simply because I started learning it recently and I wanted to share it with you. And from my experience, what I've seen is that it's the easiest and the most used one. The way Docker creates containers is based on something called Docker files. We're not going to get into the details of Docker files in this video. I just wanted to mention it very briefly if you want to do your own research. And hopefully, if I have some time, I'll create another video detailing what Docker files are and how you can containerize an application. Now, keep in mind that Docker works on both Windows and Linux. It does not work on Mac OS. So if you have a Mac computer, just toss it out of the window and get a proper computer. I'm kidding. There is a solution for that. As you're going to be seeing, I am going to be installing Docker on a VM. So you'll see that I am running an Ubuntu inside a virtual machine. And in my Ubuntu virtual machine, I'm going to be installing Docker. So this is absolutely possible. You can do that. If you don't want to mess about with your host operating system, or if you have a Mac and you don't want to throw it away, you can install a virtual machine with Ubuntu in it. And then from there on, you can install Docker on Ubuntu. Why am I using Ubuntu? Because I found it easier to install Dockers on and manage Dockers from. You'll see tutorials on mostly how to do that on Ubuntu and a few on how to do that on Windows. So I think enough talking for now about concepts and theories. Let's dive in and see how we can install Docker on Ubuntu. Like I already mentioned, this is an Ubuntu virtual machine. I've installed this on my host operating system. It's up and running. It's a fresh Ubuntu installation, and I'm going to start installing Docker on it. There's a few links that you should know about. The first one is how to install Docker on Ubuntu, and the reason being is because I'm using Ubuntu, of course. The second one is the post installation. So after we finish the installation, there are certain best practices that will make your life easier you might want to consider. We'll talk about a few. And the last one is the Docker Hub. And this is where the Docker images come from. In other words, when I'm going to install the Kali container, where is this going to come from? It's going to come from this page. So let's get started. I'm going to start with how to install Docker on Ubuntu. And to be very frank with you, it's a straightforward method. It's just copy pasting stuff. There's absolutely nothing complicated about this. The only thing you want to keep in mind is that there are two editions of Docker, the Enterprise Edition and the Community Edition. Of course, we're going to be going with the Community Edition. Now, there is one prerequisite, which is to make sure that your Ubuntu is one of these versions. If you've installed the latest one, then you're good to go. If you already have Docker installed and you want to uninstall older versions, you can do that. Mine is a fresh Ubuntu installation. I got nothing installed on it, so I'll just carry on with the steps. So first and foremost, I want to do the apt-get update. So I'll run the command and I'll wait for the update to finish. I will be speeding the video in certain places so you don't end up having to wait. So once this is done, I'll go back and carry on with the steps. I'll copy the next command, paste it. And if you don't know what these commands mean, you have two options. Either completely ignore them and just follow the steps, or you can go and do a little bit of research or take our Kali course, which goes into a lot of details on a lot of these commands and the usage of Kali and Metasploit and so on. So this is done. Let me move on to the next command. I'll do that. So that was very quick and easy. Moving on, another command. And now it's time to add the repositories. So I'll do that again, copy and paste. I'm going to skip this command because I've already done that. If you do it, it doesn't hurt. And now it's time to install the Docker container. So I'll copy this command, paste it, and wait for the installation to finish. Once this is done, I want to verify that Docker is correctly installed. So I'll copy the docker run command, and do not worry if you don't know what that means. We will be talking in details about all of these commands. For now, just run the command as is, and you'll see that it's looking for something locally. It doesn't find it, so it goes and pulls it from the library. And that is the Docker Hub library that I was telling you about. Once this is pulled, it will run the image, and you'll see a message that says everything is absolutely fine. Perfect. So let me pause here for a minute and explain in a little bit more detail what's going on. We issued a Docker command that says run an image name. Assume this image, for example, is Kali. So I'm asking it to run Kali. In this case, it's not. It's something a lot much simpler and smaller called Hello World. So what Docker did is that it tried to find this image locally on your Ubuntu installation, and it couldn't find it. So it went out to Docker Hub, looked for it on the Docker Hub page, which I showed you earlier, and then it found it and pulled it from the Docker Hub page. Once that's done, it ran it. So should I have replaced the Hello World with the proper Kali image name, I could have ended up running Kali instead. But let's not jump ahead. We'll get to that in a moment. So now I know that Docker has pulled down an image from the Docker Hub. But where is this image? Docker images is the command that will show me a list of the images that I have locally. Now, if I type Docker images, I'm going to get permission denied. The reason being is I didn't use the sudo before this command. Now, it's a little bit annoying if I want to use sudo every single time that I want to do that. So let me go back to the installation instructions, and you'll see that there's a command that allows us to add our user to the Docker group. The Docker group will have permissions to run the Docker command without using sudo. So you could either use this command and replace your user with the actual username, or if you go to the other page where you have the post-installation steps, you will find a slightly more advanced command that will just pull your username and replace it in that command. So let me copy that, and I'll go back to my terminal. I'll paste that, and now you should be able to execute Docker commands without using sudo. But before you do that, you need to log out and log back in for that to take effect. So let's do that, and then we can carry on and move on to the next section of this video. Now that you log back in, let's try and see if we can run the command without using sudo. So I'm going to do Docker images, and here we go. I have a list of images that I've pulled and downloaded from the Docker Hub. And for now, there's only the Hello World image. The Docker ps command shows me any containers that are running. So as you can see, as of now, there's no running containers. If I want to see all the containers, regardless of whether they're running or not, I do Docker ps -a. And now we have a result showing the Hello World image, but it's not running as of now. Notice also the container ID. This is a unique identification number for each container that we will be using later on. I already mentioned that all these images will be pulled or downloaded from the Docker Hub. So let's say I want to search for the Kali image. I can do that here just by going to the search field and typing in Kali, or I can do it from the terminal. I can do Docker search Kali, and we'll get quite a few different images with the name and description and the star rating and so on. Now, keeping in mind that most of these are going to be the base image. So when we did the comparison between containers and VMs, I told you that VMs install the entire operating system with all its bells and whistles. The containers are not quite the same. They are minimalistic in nature. So this will install the absolute minimum of Kali. Whatever else we might need, we need to either install it manually ourselves, or we could look for another image, let's say for example the second one, that will install Kali with Metasploit preloaded in it. So I'm going to start with the absolute minimum one, which is the official one, the Kali Linux Docker. So this is the name of the image that I want to go with. So I'm going to copy the name of the image I want to go with, and I'm going to do Docker pull and the name of the image. This is just going to download the image. It's not going to run it. When we did the Hello World, we did Docker run, and that automatically pulled the image down from the internet, from the Docker Hub page, and ran it for us. Now I'm just breaking things down a little bit more so you can understand the process of what happens behind the curtains. So I'm doing Docker pull, which is going to just download the image. Now if I do Docker images, you'll see that I have a new image coming up in my list. It's about 1.6 GBs as opposed to the 1.8 kilobytes for the hello world. Now, if I do docker ps again, there's nothing running. If I do docker ps -a, there's the hello world container that was stopped. So now I want to run the Kali image. Let me copy the name again, and I'm going to do docker run, and I'm going to specify a few parameters just to make sure that it doesn't run in its default state. I want to rename the host to Kali. If I don't rename the host name will be based off the ID of the container, which can get a bit confusing if you're running more than one container. So the -h will define the host name. I'm going to call it Kali. -t says run a terminal, a TTY terminal, and -i says show me the output on the screen. So attach to the container, run a terminal, and let me see the output of what's happening on the screen. If I don't use this, the container might run in the background. A lot of containers will actually run in the background and you will not have terminal access to them. Now I need to specify what command I want ran when I execute the terminal. So I'm going to specify the bash command, which lives under /bin/bash. When I hit enter, you'll see that I now have a prompt into my Kali container. So now I have access to a Kali container. But if I try to run any basic commands like nmap, for example, I'm going to get an error that says command not found. And this is expected. Like I said, this is the absolute minimal installation of Kali without all the additions. So I want to install nmap. From there on, it's just basic Linux commands. So I'm going to do the apt update, wait for the update to finish. Once that's done, I'm going to do apt install nmap, and then wait for that to finish. Once done, I can run the nmap command just to check and verify, and here we go, nmap is running. Perfect. So this is my Kali in a container. How simple and straightforward was that? Pretty amazing, eh? If you wanted to do that on a VM, you would have had to install the hypervisor and then download almost 4 gigs of Kali and then install it all from scratch. And all we did here was run a few commands and we have Kali up and running. Granted, it doesn't have all the tools and the additions, but that's absolutely fine. We can install whatever we want, as you just saw. As a matter of fact, we're going to be installing Metasploit later on. But for now, let me install the other container, which is the Metasploitable container. That's going to be our target to hack. So I'm going to do a docker search Metasploitable. And like we saw with Kali, we've got a few options. This time, let me show you what it looks like if I do it from the Docker Hub. It's exactly the same, only using the graphical interface. So I'm going to look for Metasploitable, and we're going to be seeing a few options. We can read a little bit more about the description of these images. So I'm going to click on the first one, and you'll notice here that it says there are no services running. You need to manually start the services. So even after you download this image and run the container, the services will not be running. You need to get into Metasploitable and start the services that you want to attack one by one. If I go to the second one, the creator who did that image had it built in such a way that it will have most of the services running, which is a little bit more convenient to me, given that I am a little bit lazy. And if somebody's done the job for me, then I don't need to redo it all over again. Speaking of lazy, I don't have to actually type the command. I can just copy it from here, which is pretty convenient. And then I can go back to my terminal and paste it. Well, that's funny. It doesn't look like it's copying properly. There goes my laziness out of the window. Actually, let me just copy the name from here. Here we go. Lazy solution found. Perfect. And then I'm going to do docker pull and the name of the image. And as we know by now, this is going to download the image. So now if I do docker run -it, which is the same command we did with Kali, but I'm just combining I and T together, and the name of the image. And here we go. I'm into the Metasploitable container. How easy was that? Now notice here that because I didn't specify the host name, it just automatically took the host name as the ID of the image. Now let me open a third terminal and just review some of the commands that we went over. Docker images will show me all the downloaded images that I have. Docker ps will show me all the running containers. So we can see here that Kali has been running since about 14 minutes ago, and Metasploitable has been running for about 48 seconds ago. And I don't know if you've noticed, when I ran Kali, I issued the /bin/bash command. When I ran the Metasploitable, I did not issue that command. Did you notice this? But if you look at the output of the docker ps command, if you look at the Kali section, you'll see that the command is /bin/bash exactly as I specified. However, the command for the Metasploitable2 was sh-t /bin/service . and this is the default command that the container ran with. Perfect. So with that, we have 2 images downloaded, 2 containers running, and we can start having some fun. We can start trying to hack the Metasploitable container. Let's get the IP address of Metasploitable and go back and scan it from the Kali machine. I'm going to be running through this, guys, because we've covered these concepts multiple times in other videos, in our free videos and in the paid courses. So we're just getting a list of the open ports. And I know that there is a port that is vulnerable on Metasploitable for a certain exploit that I want to take advantage of. And to do that, I want to use Metasploit. But unfortunately, Metasploit is not installed. So I'm going to have to install it from scratch. I'm going to use the apt install command and install the Metasploit framework. Now, this is going to be a little bit over a gig in size, so it is going to take a little bit of time. Once that's done, I can run the msf console command and I have Metasploit up and running. I'm going to search for Unreal, which targets the Unreal IRC backdoor vulnerability, which affects my Metasploitable target. I'm going to use this. And again, at the risk of repeating myself, if you're finding yourself a little bit confused with what's going on here, please go back to one of our courses that explain Metasploit or do a little bit of research online. So I'm going to set the IP target with the rhosts command. Once that's done, I'll hit run. And here we go. I have access to the Metasploitable machine. Pretty cool stuff. So in a matter of minutes, I set up my mini pen testing lab. I downloaded Kali, I downloaded Metasploitable, and I'm hacking away at Metasploitable. So now let me exit my Kali shell. And I'm also going to exit my Metasploitable shell. Now, quick recap. If I do Docker images, I'm going to be seeing the images that I downloaded. If I do Docker PS, I'm going to see that there is nothing running because I exited the Hello World, I exited the Kali Linux, and I exited the Metasploitable2. If I do Docker PS -A, it is going to show me all the containers that I have. Now, what if I wanted to delete one of these containers? I can do Docker RM, and I can use the ID of the container that I want to delete. Now, if I do Docker PS -A, you'll see that the Hello World has been deleted. What if I wanted to delete all the containers all at once? I can do that using Docker container prune. Now this is going to delete all the stopped containers. So I'm going to answer yes because all my containers are stopped. And once this is done, if I do Docker PS -A, you'll see that I have absolutely no containers left. But I still have the images left. These are the images that I pulled from Docker Hub. So if I do Docker images, here's a list of my images. If I wanted to delete one of these images, I use the Docker RMI for image and the image ID. And this deletes my Kali image. Now, if I do Docker images again, Kali is no longer there. Can I also delete an image using an image name? Of course you can. You can do Docker RMI and copy and paste the image name. And here we go. If I do Docker images, I no longer have any images left. Docker PS, there's nothing. Docker PS -A, there's absolutely nothing. And Docker images, no more images left. And with that, I've cleaned my system. I've deleted my Docker containers, my Docker images, and I freed up all the space. So as you can see, this was pretty straightforward, pretty easy way to install containers and to play around with Kali and with Metasploitable without having to go through the hassle of downloading and installing a hypervisor and then downloading and installing Kali from scratch, doing the same for Metasploitable, and so on. Now, please keep in mind that I'm not bashing virtualization. I'm not against virtualization, not at all. It definitely has its advantages and its uses. In this video, however, what I wanted to do is just show you quickly what containers are, what Docker is, and how you can install Docker on your Ubuntu, how you can install Kali and Metasploitable and play around with both of these images. I hope you enjoyed this video and you found it useful. And until I see you again in another video, happy ethical hacking.